Okay, last lesson we learned like to sketch for this graph. We find the dy dx, we make it equals to 0, we find one stationary point, which is, my laptop got really naughty today. Okay, I got my dy dx equals to 0, and I have x equals to 0, y equals to 1. So that's the stationary points. And I find a point on the left, I find a point on the right to evaluate the derivative. And I can see there's stationary point of deflection. And also I'm trying to find for x-intercept. I'm trying to find for x-intercept, but I can see there's no x-intercept. And I want to see the behavior when x approaching to infinity. I can see the y value get really large. And when I'm trying to evaluate x's really small numbers, this y value approaching to 0. That's why I have this conclusion. The shape mass looks like this. Okay, so that's what we learned last lesson. So today this graph will basically follow the same method to do it. So first of all, we need to realize that is the product rule. Okay, that is the product rule. I see a lot of you directly do 1 over x. That's the derivative, because I think you didn't see the x in the front. So if it's x times log x, there's two different functions times together. We need to use product rule. So the dy dx equals to log e to x plus, well, that's the derive for this. And now we keep x. We derive for log e to x. That's 2 over 2x. Okay, that's 2 over 2x. What's wrong with it? Okay, it's 2 over 2x. I can't write. Stop. Okay, and after that, I will make it equals to 0. I will make it equals to 0. So when I solve for x, I should have x times 2 over 2x, and that's log e to x plus 1. So I will make it equals to 0, solve for stationary points. And then that will give me log e to x equals to -1. And that gives me 2x equals to e to the power of -1. So x equals to, well, 2x equals to 1 over e, and x equals to 1 over 2e. Okay, so that's the x value of the stationary points. And now I will substitute that into the y function to see the coordinates. That's 1 over 2e times log e, 1 over e. That gives me y equals to -1 over 2e, because that will give you a -1. Inside is e to the power of -1. So I drag the -1 into the front, I get -1 for the circle, and then times with 1 over 2e. That's -1 over 2e. So what I have now, stationary points is 1 over 2e, comma, -1 over 2e. That's the stationary points. Now we will work for the sign diagram. Okay, we'll work for the sign diagram. We have x, we have dy dx, and we have the graph. Okay, so we have 1 over 2e in the middle. 1 over 2 is definitely a number in between 0 to 1, right? Less than 1. Now, your domain is 0 to infinity. It will be easy to evaluate the right-hand side. Let's say we select a 6 or a 4 on the side. Okay, it doesn't matter what really you select. So if I select 4, what I will have is, it's 2x. So I can select just a 1, basically just a 1. So what I will get is log e 2 plus 1. Right? Log e 2 plus 1. Substitute into the dy dx. Okay, into the dy dx. Or you can even select a half, that will give you 1. Right? You select a half, that will give you 1. Because half times 2 is 1. Log e1 is 0, and dy dx will be 1. So doesn't matter what you really select for this part. It's really easy to calculate. So I have log e2 plus 1. That's definitely positive. I know this part will be 0. I know it's a horizontal line here. Now it's the left. Okay, I select a random thing on the left. Let's see what will happen. Okay, E is 2.7, right? E is about approximately 2.7. Let's say is 5.4 somehow, 5.4 at the bottom. And if I say that's 1/6, that will be smaller than that. Well, don't write it in. Let's see what will happen. If I put 1/6 there, the dy dx, well, x equals to 1/6. My dy dx equals to log e a third plus 1. Right? Do you know log e a third is positive or negative? It's positive or negative. We learned this before. How do you decide? Give me an answer. Have a guess. Okay, what I said the base and the number, you look at two places. If they both greater than 1, or if they both in between 0 to 1, it's positive. If one less than 1, one greater than 1, it will be negative. So whether it will be positive or negative. Negative then. Okay, this is a negative number, but I don't know how negative it will be. Okay, so I can't say directly, oh, it's less than 1, or is less than -1 or greater than -1. I can't tell that yet. Okay, I can't tell that yet. So, well, there's one way we can do it. What we can do is, I can make this become 1 minus log e3. Right? I put the negative into the front. Okay, and what's 1? What's 1? 1 is log e, right? dy dx is log e minus log e3. Okay. This is larger or this is larger? E is larger or 3 is larger? 3 is larger. So which number is larger? Front or back? Back one is larger. So overall this is positive or negative? Negative. Okay, that will be negative. So that's how you can decide it. It's hard to evaluate, but it's still possible to evaluate. So what I can do, this is, I need to put values. That's 1 minus log e3. So that's a negative. You need to convince yourself, okay? You can't have a guess. I think it will be positive, and the number I write out, I don't know whether it's positive or negative. It's very, if you can't convince yourself, I won't give the mark. Like, because I need to clearly see, okay, I can tell from that point it's positive or negative. Another way we can do this is, instead of comparing all of that, I will make my x become this. I times another e, say this is this column, okay? I times another e here. This is a definitely smaller number, right? Smaller compared to 1/2e. So let's have a look what's dy dx equals to. Log e times 2, so it's 1/e squared, and then plus 1. What I have here is a -2 plus 1, and that equals to -1. So can you see that's an easy calculation here, but only if you can think about this x value. You can create something which can be easier for you to calculate. So you can choose 1/6, 1/7, 1/8, but it's a little bit harder to discuss that after you substitute. But if you can select something good enough at the beginning, I can really do an easy calculation to see whether it's positive or negative. So it doesn't matter, as like you can select the way you like. Okay, which one works for you, you use for that. So now I can see this is a minimum turning point, right? local minimum turning point. That's what we have. That's the stationary point we have. Alright, what's the next step? I have find the stationary point, I have find the nature of it. What's the third step? What we're trying to find? XY intercept. Okay, I don't have y intercept because x can't be 0. Okay, 0 is out of the domain already. Give you the domain because of the log e. You can't have 0 in the domain. So let's work for for x intercept. So when y equals to 0, log e x times log e to x equals to 0. So it's either x equals to 0 or log e to x equals to 0. Well, definitely I can't have x equals to 0 out of the domain already. So it can only be log e to x equals to 0. So 2x equals to 1. X is a half. So x-intercept is a half comma 0. Okay, also a half and 1 over 2e. Inequality sign, smaller or greater? Smaller or greater? Greater. Good. Okay, greater. So we have turning point first, and then we have the half. Okay, that's the x-intercept. So let's put the information we know. Here. Well, because domain is only 0 to infinity, I can draw like this. Okay, 1 over 2e and minus 1 over 2e. And it's the minimum turning point. So let's say this point is here. 1 over 2e minus 1 over 2e, which is here. And then a half is say a half is here. Okay, I know the scale is not very good, but I just want to show a bigger graph. So a half comma 0 is here. Okay, a half comma 0 is the only x-intercept you have. Okay, remember that. We'll use this fact later. That is the only x-intercept you have. Okay, you solved it. You can't solve out anything. That's the only thing you have. Now the only thing worries, well, the shape will kind of looks like this. Okay, shape kind of look like this. Only thing worries me is when x equals to 0, for the 0, what the graph will look like. You can't get a sudden stop. You should like 0 is last point or asymptote. What do you think? Asymptote? Okay, I will draw this as asymptote. Okay, I'll use a straight line to show if x equals to 0 is the asymptote. If it follows the nature for log, we have the asymptote there. Okay, my graph will look like this. Can anyone tell me a problem here? What's the problem? What's wrong? Like this graph is definitely wrong. What's wrong? Very easy thing. I have mentioned another x-intercept. Thank you. You have another x-intercept. There's no way to avoid another x-intercept. And as you know, you don't have another x-intercept. Well, it doesn't matter what the shape looks like. Doesn't matter how you're trying to sketch for this graph. I only have one turning point. I only have one x-intercept. I can't have this shape. Okay, that's why you can. Well, at the beginning, I think it's asymptote as well, and I try to sketch it, and I said, no, this can't work. Okay, that's the investigation step. No one will directly know what the graph looks like. You need to try. That's why I ask you, what do you think? Most of students will think that will be asymptotes, and I show you why it can't be asymptotes. Why you need to say no to your thinking, assumption. So we won't have this one. What's another possibility you have at that point 0? You can have open circle. Good. Okay, where the open circle will be? 0, 0. Why will be on the 0, 0? Very easy reason. If it's not, well, let's say if it's not on the 0, 0, it's somewhere above. Again, still have like to x-intercept, still can't work. But if you have it like below, you might not have x-intercept, but it doesn't make sense. It does. Why it doesn't make sense? I can't get rid of. It's okay. Give up. If we have open circle here. Okay, like this. Okay, it's all fine. Okay, nothing really wrong so far. Okay, but let's have a look at the value. Let's have a look at the value. We have a negative value here. Okay, we have a negative value here. But how we get that point? Like, it's an open circle, which means we try to approaching. It's kind of a limit. We're trying to approach into that point. But when you put 0, think about you put 0 here. Okay, put 0 in this equation. We have 0 times log e, something approaching to 0. Okay, something approaching to like really, really small, tiny numbers. It will become 0. Okay, 0 times anything will get approaching to 0. That's how you say, okay, my point should be at 0, 0. Otherwise, there's no other value you can find out. Okay, there's no other values you can find out. So that's why it must be at 0, 0. Because if this x approaching to 0, the whole equation will approach into 0, regardless how the log ex behave. Okay, so that's why we must have this graph at 0, 0. Okay, then we have fully sketched for it. Okay, we have fully sketched for it. Questions? That's a really good question. Okay, that's a really good one. I really like this question. It's really help you to think about things. Okay, you can't know the answer. This is not something you have learned. It's not a function you learned before. That's how you decide. Okay, using all the knowledge before to put into this graph. Okay, what the graph should look like. Why it can't be the way I think I thought before. Okay. Any questions? Okay, if you don't have any questions, can you have a look at example 2, please? Sorry, we don't have much time. I'll just quickly go through that because it's more important for the last example. Okay, the curve with equation y equals to x cubed plus 2ax squared and bx plus c pass through the point 0, 5. Well, polynomial, you know c is 5. That's something really direct. Okay, c equals to 5. Something really quickly can find. Okay, the next thing is important. Now, start from now, when you see stationary points and give you the coordinates, there's 2 possibilities. Not 2 possibilities, like 2 things you can get from that. First of all, is substitute the point into the equation. 7 equals to 8 plus 4a plus 2b plus c. Okay, that gives you 4a plus, the c is 5, okay, plus c is 5. 4a plus 2b equals to minus 6, and 2a plus b equals to minus 3. Okay, what's the second piece of information you can get? Well, that's everyone can see, like from year 11. Like, I substitute the point. That's a point on the curve. But it's a stationary point. What's the second thing you can tell? What is a stationary point? What's the common features that stationary points share? Okay, what's gradient? Derivative equals to 0, right? So So I will find dy dx. dy dx is 3x squared plus 2ax plus b. Okay, when x equals to 2, dy dx needs to be 0 because x equals to 2 is the stationary point. So another thing we can have is 0 equals to 12 plus 4a plus b. So what we have here is 4a plus b equals to negative 12. Okay, we subtract them. Minus 2a equals to 9. A equals to negative 9 on 2. And we sub back into that one. Minus 9 plus b equals to minus 3. And b equals to 6. Okay, sorry I go this very fast, but I don't have time. It's all calculations after that, but the only important thing is stationary point will give you two pieces of information. First piece is this point is on the original graph, and second piece is stationary point means derivative equals to 0. When you have stationary points, you know when you sub that x into the derivative function, you will have derivative equals to 0. So actually you only have one piece of information. That's two equations you have. Okay, two equations you have. Okay, if you haven't finished, just copy this line and copy this line, and we need to move on. There's more to talk about. Okay, get those two equations and you can solve out a and b. So a, b, c values all there. Okay, it's easy to work out that. Let's skip 3. 3 is not that important. We can go back to that, but we want to have a look about 4 disappeared. You can add example 4 here. Well, I will just use the space for example 3. Okay, let's sketch example 4. Example 4 and example 5, they are the same type of questions. Okay, we have y and x. Okay, so we have that point A. Well, just randomly draw a graph looks like what I have sketched here. Have A, B, C here, and that point is D, M, P, P, Q. Well, I'll say that's M, N, and P, Q. Okay, so we have a diagram like this. Not saying that's Y, that's F dash X. Okay, F dash X. Okay. For example 4 and example 5, they both require you to sketch. Okay, this question is asked you to sketch fx. I like a possible graph. I'm not going to write a full sentence. So sketch a possible graph for fx. Okay, sketch a possible graph for fx. So I have my fx like this. Okay. Let's have a look at example 5 first, because I think 4 is harder than 5. If you can read example 5 first, and give you a hint, use the sign diagram table. Okay, use the sign diagram table. Sketch a graph of a function with rule y equals to fx. Given that f1 is 32, f5 is 0, and 0 equals to 25, f dash x equals to 0 when x equals to 1 and 5. Okay, before it's all talking about the coordinates on the diagram, it's nothing really interests me. But when f dash x equals to 0, I know that's where I can start. I know that's how I can set up the sign diagram, like the sign table. Okay? So for this one, We always need 3 rows for the sign diagram. We have x, f dash x here, and the graph. We know that we will have first one empty, second one is the smaller number, which is 1. And the next one will be empty again, and the next one is a 5. Really need that. We know the derivative equals to 0 at 1 and 5, and I know they are horizontal point. The next, that's what I can get from the first row, okay, and also some coordinates there, but like I'm not worried about that too much yet. But what I know now is f dash x less than 0 when x is in between 1 and 5. In between 1 and 5 is any number here is in between 1 and 5. We have something negative. Minus VE, I'll say negative here. Okay, negative. So I have decreasing equations here. F dash x greater than 0. When x less than 1, I have positive gradient here. And x greater than 5. Positive gradient again. I don't need this row. This column, no. So I have increasing gradient and increasing gradient. Can you see the shape of fx now? Like this is actually called the graph of fx. Okay, that's the graph of the original, so it's the graph of fx. Can you see the shape? It's something like this. My sketching is too bad. Okay, something like that. And you know this point is 1,32, and this point is 5,0. Okay, it's all given in the coordinates. Okay, you see the coordinates above. I know that's the coordinates. So I can sketch this here and sketch the y, x here, x here, and also you know this point is 0,24, is it? 25, 0,25. Okay, that's a possible graph. That's a possible graph we can get from this, okay, from this description here. Get it? This question is appears in the VC exam in multiple choice session for a couple of times, like this type of question, like give you the information for derivatives. Well, this one is easy. Okay, the above one is harder. Give you the information about the derivative and ask you the actual function. Okay, the actual function for the graph of the actual function. When you finish this one, let's have a look at this one. This is how the exam multiple choice questions like to give. Okay, something like this. What point you think is important to you? Like A, B, C, D, M, N, P, Q, what do you think is important to you? Like what you will look at, or say how you can set up the diagram. How you can set up the slope diagram. What values you use? A, B, C, M, N, P, Q, which one you use? Let's change another way to ask. Stationary points, right? You need the stationary points in the actual table. Okay, in the actual table. What is stationary points? Okay, what's the common feature for stationary points? Okay, gradient is 0. Change another word. change some notation on this graph, what should be 0 to be a stationary point? Everyone wake up. So hard. Okay, some notation on this diagram. What equals to 0 will give you stationary point. X equals to y equals to 0. F dash x equals to 0. Okay, x-intercept. Derivative equals to 0 will give you the stationary points. So it will be this point, and this point here. I don't care about what's M, what's Q, what's P, what's N. Okay? So it's useless information for the turning points on the derivative graph. I don't care where it turns. I don't care what's the value. What I only want to see from the derivative graph is the ABC. Okay, the x-intercept, in other words, is the x-intercept. Okay, I will set up the table. I don't know where I can draw the table. Draw it too big. Well, let's draw the table here. Okay, I have three stationary points. I have x, f dash x, and the graph of fx. The first one I have A, empty. Second one I have B, empty. I have third one C, empty, and I have last one. Well, I'm so sorry for looks so bad, but it makes sense. Okay, I write things in order from the smallest to the largest, and I will talk about the negative or positive in between that points. Okay, so first of all, we know that A, B, C, they got gradient equals to 0, like this. Okay, when x less than A, the derivative is positive or negative? Think about it again. Derivative is positive or negative when x less than A. Okay, let's say when x equals to E, what's f dash E gives you? Negative value or positive value? Negative or positive value, everyone? Positive? Where's your x-axis? Here's your x-axis. When x equals E, f dash E is positive or negative? Negative. Good. I want to hear that. Negative. Okay, it's negative. You're not looking at the shape of the graph. You look at it whether it's above x-axis or below x-axis. In between A and B, positive or negative? Positive. Good. And in between B and C, positive or negative? Negative. And after C, negative again. Okay, so it's decreasing, increasing, decreasing, and decreasing. So if I move this up a little bit, you can see the shape of the graph. Okay, so this point got A comma something is the minimum. This point is B comma something is the maximum. This point will be C comma something is the decreasing stationary point of inflection. That's how you use the f dash x graph to go backwards to find the original graph. Okay, you look at different things. On the fx function, you look for turning points. Okay, and then whether up or bottom for the derivative. But for f dash x graph, you only look at the x-intercepts, and then you look at whether it's above the x-axis or below the x-axis to talk about the gradient. Okay, you look different things on different graphs. Okay, fx and f dash x, you look at different things. We rushed through this today, okay, because we don't have enough time. You need to go back and think about those two questions carefully. Okay, it appears in this exam quite a number of times. Okay, especially this one. Okay, especially this one.